Hello, everybody. We are Vera. I'm Corey.
I'm Joshua.
I'm Christian.
I'm Parsa.
I'm Adam.
Our project was to provide locomotion and mobility accessibility to individuals in virtual reality research studies. So our project was twofold. First, we wanted to target the developers who are developing the products for people to test out and participate in their studies. And secondly, the participants who are actually going to be participating in the studies to provide them the ability to navigate in the environment. So we wanted to look at how these people actually, how do they navigate environments in real life? And we looked at the devices that they used. One of the ones that we primarily targeted was the sip and puff device, which is, for those who don't know, it's a straw that people hold in their mouth and then they can blow or sip into it, and that will allow them to control their wheelchairs or a tablet or whatever other devices that they need. Similar devices like this are a mouse joystick, a head array, anything else like that. What we saw with these devices was that consistently throughout them, they all rely on primarily 4 buttons or more inputs. So we thought if we could provide the ability to navigate an environment with 4 buttons, then any individual with any type of device, whether that be a mouse joystick, a sip and puff, anything, they would be able to navigate the environment so long as the programming allowed them to navigate it with 4 buttons. So along those lines, we wanted to target 4 specific areas of navigation. That is movement, looking, interacting, and navigating a menu. And if we can do those 4 things in virtual reality, then they can fully navigate and interact with their environment. So we additionally have it so that you can use the 4 buttons to do this through a tab enter approach, which is what most websites use for accessibility. It's also what Apple uses for their switch controls for devices if you don't have access to tapping on the screen. And that is to basically be able to tab through elements and highlight different elements on the menu, and then you can select an element in that menu to actually activate its function. So we, to test this out, we went ahead and made a device, which Adam will show you here. It's a little Arduino device. We wanted to get an actual sip and puff device, but those are upwards of $1,000, so we didn't have the funds to do so. So we decided to make a device like this, just so that we can kind of test it out to make sure it works with any device with 4 buttons. And thankfully it does. So we kind of hope that that means that any device that relies on 4 buttons, if it can work with this, then it can work with whatever, the sip and puff, the mouse joystick, anything like that. So now I think that we can actually do the demo, which Josh is going to go ahead and run that.
So, hello everyone. As you can see on the screen, there are, there are 4 submenus. We have look, move, interact, and settings. Below we have our control scheme. 1 and 2 allow us to scroll through a menu. You can continuously click. 3 selects into a menu or selects the button, while 4 is our backward go back into the submenu. So first we'll look at our look feature. As you can see, the user can either look up or down. So if I wanted to maybe look up at something, I'd be able to do that, and maybe look down a little. And then when we restart our view, we get back to the default view. Then we'll go back here. Next, we'll look to move. So with our movement, the user they move forward and then they rotate their character, either turning left or right. So we'll go into the menu. Let's say we want to turn right a little. And then we go back to move forward, and then you can move forward. And now we'll turn left. And then in order to showcase our interaction menu, I'll bring this to our interactives. So let me move forward a little. As you can see, there's a lot of constant tapping. I'll showcase how we have continuous movement in the settings after this feature. So as you can see, we can highlight nearby interactables. As you can see, the key on the box has been highlighted. Then we select the interactable, and then we can view our interactions for this key. So we're able to pick up the key, and as you can see, now the key has been locked onto the player character. And as we go back, Now, I'd like to adjust some of the settings here. So as we saw earlier, I had to constantly tap with my hand to move. Now to alleviate that and allow it to just hold press, I just click here. And let's say I want to move a little faster. Let's adjust that. Now I'll move a little faster. And let's say if I turn degrees, I like to maybe just have a little more control over my radius. So let's go to, it should go up to, actually no, let's go down to 15 degrees. And we also have our menu tilt, which angles the menu. Basically, if you're looking at it with the headset on from a different angle, you'll be able to adjust accordingly. So, and menu height, same here, adjust how high the menu is on the player screen, and the menu opacity is how visible it is. So we can go back here, and now you'll see that now turning is more, or sorry, moving is more continuous. And now with this key, we're gonna go to the lock door. So now we just move forward. As you see, it's continuous movement. I don't have to lift my finger off the key. Up, and I'm maybe went a little too. So and then. And I believe now I can go through the door. Let me step back.
It's lock the door.
Okay.
It's locked.
And then, okay, there.
It's not interactive.
Okay, there we go. So we see here now with the interaction, we can open and close the door. And I might be a little too close to the menu. Let me just turn around a little.
Yeah, that's okay. I think that for time constraints, so that we can allow other people to come in, we'll kind of leave it there. That you can kind of see how it works. You can see, you know, we want to try to make it customizable for the researchers and make it able to be used by the participants. And yeah, so that's pretty much everything we have. Thank you all so much for your time. We hope you liked it.
Hello, everyone. My name is Abraham Gallagher, and I'm an assistant professor at Gallaudet University. Here I'm presenting a topic called automatic captioning in live virtual reality presentations. The last name is Glasser. So it's a very small study. It's just a preliminary study focusing on 3 different captioning behaviors in VR environments. They are as follows. One is called appear, and that means wherever you look at that moment, the captions will appear at the bottom of the screen. The second type is called headlocked. The captions will follow the movement of your head simultaneously. Wherever you look, the captions will appear. So there's no lag, nothing of the sort. It just moves with your head. That's headlocked. The third type is very similar, but it's called lag. So it's wherever you look, a few seconds later, the captions will appear. Just a few seconds later, a little bit delayed. This was, as I said, a very short and small study. It was undergraduate research for a 10-week project, and we only had the opportunity to collect 8 participants. So because of that, we don't have any significant results, and statistically speaking. However, we have some good discussion points regarding each point. And I have them listed here. And overall, Participants did not like the appear mode. They preferred the headlock or the lag. Participants also gave some feedback about the captions themselves. For example, the background color, the size of the font, the size of the box. And because we decided to keep the captions stagnant, we didn't want to add more variables in. We just wanted to check how they appeared versus how they were printed or looked on the screen. And that's the main point of this poster. I hope that you will look at it and learn more information. And thanks so much.
Hi, my name is Harish Lingham, and I am a consumer software product manager who has worked on mobile and web products. I primarily worked in the health, civic, and mobility tech domains. Previously, I worked in health sciences, both as a student and as a laboratory researcher. My poster is about understanding how crowd AI efforts such as Project Sidewalk can be used both to benefit from assistive AR development and design. And I performed a case study of Project Sidewalk, which is a project of the University of Washington's Makeability Lab. And I participated both as a direct participant, as a volunteer in the project, and also as an observer. The project's overarching vision is to label and assess sidewalk accessibility issues for every sidewalk in the world. And to date, it has been launched in 7 countries, over 20 cities, and 17,000 kilometers, and has generated over 910,000 image-based sidewalk accessibility labels. The project works by leveraging crowdsourced and AI techniques. And the way that it works is users log into a web-based tool to complete missions. And these missions allow users to see a Google Street View image of a particular sidewalk and then assign one of 5 issues, namely whether or not it has a curb, a ramp, an obstacle, or a pavement issue, a surface problem. And then a second component is then assigning a severity score to the particular issue. Volunteers are recruited in a number of ways. However, the value is twofold for participants. A, they get to develop critical thinking skills, problem-solving skills, and even learn about the methods and tools being used in the implementation of the tool. And it also provides an opportunity for workforce development. Secondly, there is an opportunity for city planners and ADA coordinators to use this information to plan more strategically how they invest their resources for repair of sidewalk accessibility issues. This is an example of an image, of a set of images rather, showing labeled accessibility issues. And just to point them out quickly, this is an image of a tree impeding sidewalk accessibility, a fire hydrant, parked car, a pole, garbage recycling can, stairs, vegetation, and height difference. And then in this screen, we see the actual severity assessment dialogue. So these missions are designed to be engaging for users. They've designed both a desktop and a mobile-based version of this using gamification and milestones and achievements and badges to kind of incentivize progress. But beyond the gamification, there are benefits, as I mentioned, from an educational standpoint. And so Project Sidewalk is really leveraging this tool to create community science and service learning opportunity. Number two, it has been shown that digital civics can support accessibility education and drive pro-social behavior. However, the tool is limited for people with motor disability and blind or low vision users. Three questions that emerge from this case study are namely whether or not image-based sidewalk accessibility can be leveraged for assistive AR design. Two, what are the challenges and opportunities of trying to do that from the standpoint of extrapolating 3D cues? And I'll come to that in a second here. And then finally, can mixed reality headsets be used to broaden participation in crowd AI efforts like Project Sidewalk? This is an image taken from the research of Dylan Fox and Shiri Azencott's team, namely comparing a wall block cue with a heads-up cue. And these cues are oriented around an image of a barrier in a room. And to the right is an image or a set of 4 images depicting a HoloLens, a depiction of a merged real and holographic obstacle, a person avoiding a real obstacle, and avoiding a holographic obstacle. And the purpose of including these images is to drive home the question of whether these image-based accessibility labels might be leveraged for generating these types of cues in some way. These cues require, or in some cases require, training and validation of their own. And given the labor and resources required to do so, if there is a way to leverage the wide-scale labeling through Project Sidewalk, it may help or may be beneficial for innovation, design, and assistive AR. That concludes my presentation. I appreciate the opportunity and would welcome any questions from participants. Thank you very much.
Cool. So I am inspired to create this project from a small concert at the Met. There was a historian talking about her research done on banjo and how banjo's history is tightly related to Black history and slavery history. With the interest on that, I dig into some search and realized a lot of banjo are not properly preserved. So from the current photos, I created some 3D models and displayed in the virtual reality environment. And later on, I realized I can create a thesis project based on the current one. I used 3 different design templates to making sure all my design thinking, mission, activities I planned for users and the expected outcomes are aligned together. And along the way, I try to apply as many learning theories as possible in the content because my major is learning technology and experience design. Something I really focus on are multimedia principle and emotional design because in advantage of virtual space is we can apply many medias in the virtual space, but it also can easily get overwhelming. And same with the slavery history, the emotion can get very heavy. So from managing the multimedia elements in the space, I try to making sure people are enjoying this experience, learning things, feeling the emotion I felt during the concert, but also not overwhelmed during the experience. I also try to apply situative learning, means ask learners to join the context from the history, actually learn the individualized stories from historical figures. And also my own experience in museum is I easily to get lost. So I really try to give a clear guidance for all my users in the experience. I did conduct some literature review. There are virtual reality museums developed in Europe, Malaysia, and North America, and user research was conducted globally. Majority of people have positive expectation for virtual reality museums. That also gave me more confidence to keep developing this project, and that's about it.
All right, my name is Florian. I'm here to present the poster Inclusive VR at Work. You can find it online. This is roughly what it looks like. But you will find it online. Anyway, so let me tell you what the basic idea is. So a couple of years ago, we started to use VR glasses to help people with visual impairments. The idea is that VR is really flexible, so you can adjust basically anything. You can adjust the environment, you can adjust lighting, you can adjust the size of content, colors, contrast, and all that. So it makes it a really flexible tool for people with visual impairments. Now, the next step for us was to think about what happens if multiple people want to collaborate. And the problem there, of course, is that everybody has different needs, right? So we need different adaptations for different people. And this is what we're working on in this project to make this possible. And the way we do it is that we basically translate interactions between those different worlds. So let me give you an example. So let's say in my world, I'm pointing towards a specific word on, for example, a PowerPoint slide. Then in your world, you will see my virtual representation, which is the VR avatar. And that avatar will point to the exact same word in your world, even though in your world, that word might be at a very different location because of the adaptations that you might use. And that way, everyone can have their individual adaptations, and they can still work together. And ideally, you don't even have to know about the adaptations that other people are using. So best case scenario is you don't even have to disclose your disability if you don't want to. So everybody can work seamlessly together without any problems and still have the adaptations that help them use the technology. That's at least our goal. Thank you.
Hi, my name is Caitlin Yeomans. My pronouns are she, her, and I am the Virtual Engagement Coordinator for the Mental Health and Addiction Association of Oregon, or MHAAO. And I am introducing this poster today titled Recovery Reimagined, Making VR Accessible to People in Recovery from Substance Use Disorder and Mental Health Challenges. My co-authors are Diana Alleman, the Marketing Manager at MHAAO, and Demetra Adams-Kane, the Grant Coordinator at MHAAO. This project is called the Recoveryverse, a larger VR project. We are in partnership with Unity Recovery in Pennsylvania, who has kind of led the charge on this. And what it essentially is VR builds that are specifically focused on having people with mental health challenges or with substance use disorder attend recovery meetings, socialize, and de-stress. So currently we have 3 platforms that the build is available on. It is available on Frame VR, which is accessible via headset, computer, tablet, and one other thing that I can't remember right now. Cell phone, that's the other thing. And it's also available on Horizon Worlds with the MetaQuest headsets, as well as on Decentraland through the computer. The majority of the meetings happen currently in Frame VR because it is the most accessible. And to get to those builds, you would go to framevr.io/recoveryverse-campus. In this poster, you can kind of see our first demo at Pure Apocalypse, which is our local conference at the Oregon coast. This is the first physical introduction of these builds. We also have our folks from Pennsylvania in there in the photo that you can probably see digitally a little bit better. So we are essentially just trying to help people who are in recovery have more access to different mediums to attend meetings, meet people, and as we saw with the COVID pandemic, you're not always going to have the option to be in person, and especially with mental health challenges or substance use disorder, you might not have an option to be in person at all, and this can be a way to get that immersive and 3D experience. think that's all I want to say. Thank you.
Hi, I'm Michael Schaubs. I am an experienced design grad student at San Jose State University. And I'm here to talk about actually my thesis project, which is called Speakeasy, using voice-driven AI for tailored immersive experiences in virtual reality and mixed reality. So I'm still towards the end of my preliminary research, but essentially originally I was holistically looking at XR accessibility, identifying the gaps, and based on survey results, literature review, and also interviews, voice commands seem to be a feature at which people wish that were improved on more. More importantly, I found that there are many people, my son included, who has low fine motor skills, and people who may not can't be able to utilize their body, their hands, their limbs in a way to be part of these VR or mixed reality experiences. Therefore, they can't really use controllers or sensors on limbs that may not be usable or are not there. So thinking about a way to just put on a VR or MR device and have an assistant to dynamically create your experience, adapt to your own personal needs, not only is an inclusive design approach, but ends up being a universally designed way of thinking when we're talking about personalization for everyone. But essentially, this project itself will be co-designed with people who absolutely need this kind of attention at first.